We're going to work with basically with only 4 data layers, all right? 3 vectors and 1 raster. And we're going to manipulate them. So we're going to do our first manipulations of data today, okay? The first vector we'll work with is the one that says schools. So I'll just load that in as a layer here. Just the one that says schools. I'll click just OK, and it shows up. It'll be these X's, okay? The next one I'm going to load is fire stations. It's another points file. So I'm going to find it here. I am going to change the symbol just so we can differentiate them on the map. I'm going to use squares, okay? So just click OK on that. So now we have X's for the schools and squares for the fire stations. I am also going to load in a vector lines file. I'm going to use roads, okay? So that's just, or streets, I guess it's called, down here. I'm going to click OK. And it's going to show up with a lot of stuff right now. We're going to deal with that in a little bit, okay? And then underneath all this, I'm going to add the raster data set that just says elevation. Not elevation shade, just the regular elevation, okay? I'll click OK. Yeah, that's the raster one. So we'll use the add vector tool, which is here to add the vector ones. And then the other one over here is the add raster map layers. That's how we're going to get the elevation in, all right? So what I'm going to do is to arrange these things so that the elevation is on the bottom. The streets I'm gonna uncheck for now so we don't have to look at the craziness, right? And for the moment, I'm just going to zoom in manually over here, just so I'm looking at generally the extent of the raster elevation map. All right. So I'm not changing any region settings. I'm not doing anything for now because we'll get into that next week. We're just going to zoom in manually like this, and this is what we're going to do. Okay. So the first topic is to simply query by attribute. So we remember what a query is, right? Everyone remember what a query is in general? Anyone want to volunteer? Just a brief explanation for the class? Just like a search, pretty much, right? And we can query multiple ways. We can query by X and Y coordinate if we happen to know those things. I'll just say I very rarely know a specific X and Y coordinate that I want to query, but sometimes you might, right? Especially if you have GPS coordinates or something like that. Yeah, something like that, right? Very often, however, we'll have a data set like this where there's actually information in a table in this vector data set. And we want to query by some piece of information in the data table, and we just want to extract the features, the physical features, the spatial features that match that information, right? So we're going to query the schools, okay? So the schools layer here. The first thing I'll do is just select the schools, and then I'll push this little button here that says Show Attribute Data for the selected vector map, all right? So I'll just click that button, and the data table pops up. And this is very similar to like in QGIS where you show the attribute table. It's the same idea. And if I bring this over, we can actually see that this is a fairly standard table, just like an Excel spreadsheet, okay? And there are a lot of attributes in this particular data set attached to each point that is a school, okay? Just a quick overview of how the GRASS attribute table works. The initial view is just to show the data, just like a table view, right? You could also click down here. There are 3 tabs. The next one says Manage Tables. This actually just shows the columns, the names of the columns right over here, what data type they are, whether they are character, which is alphanumeric text, right? If they're integer, they're just 1, 2, 3, 4. If they're double, then they are with a decimal point. And then there's also, I think, date time is the other one that it could be. All right, so if you just scroll up and down, you can see which type each one is. And the length, remember, that's the number of characters that can go in the field in the database. It's fairly standard database stuff. All right, so in this area, we can actually add columns. We can change their characteristics for other columns over here. And then the third tab is something totally different that you haven't seen yet. You haven't seen it in QGIS because QGIS, and we've been working with shapefiles, uses a really old, very simple database backend. GRASS uses a modern, really complex, powerful database backend. We can actually have multiple tables associated with the same vector file. So we have like just one set of points, all xy's. We're going to have one table that's got one set of information. We can have a whole different table. We can have any number of tables. Any number of tables we want attached to the same vector points file or vector polygons or whatever it is. Typically we only have one layer, all right? But sometimes you'll get data that'll be like 5 or 6 tables, depending on the point of the data set. The actual x and y coordinates are not stored in the table that we're looking at here in the first layer. They're stored in a separate invisible layer. We call it layer 0 in graphs. All right? So each table we're going to call a layer. It's confusing because it's overlapping with the idea of actual physical layers. All right? But there's database layers as well as physical layers. So the layer 0 database is actually a list. It's got a unique identifier number for each individual feature, and then XY coordinates. If it's a point, it's only got 1. If it's a line, it's got at least 2. If it's a polygon, it's got at least 3, right, to define those things. Okay? We almost never, ever interact with that layer, but it's always there if you have a vector file. So that's just to know. The table that we think of with the data is typically layer 1. And this is going to be important a little later because we're going to have to query, we're going to have to tell GRASS which piece of information we want to query, which database layer we want to query, right? We'll get to that in a second. It'll become a little bit clearer. The point is that we can add layers here if we wanted to. We could add extra tables. We can attach tables. We can do all kinds of database manipulations from this interface here, because it's not just showing us the data. It's actually the manager for the database. All right. So we already looked at having, being able to query by clicking on things like that. That's real simple. What we want to do is actually build a real database query where we say, find all the attributes that meet my criteria, okay? And this will be using our logical operators that we talked about last time. Things like equal to, less than, greater than, not, that kind of stuff, right? We can build a query directly in here, and certainly that's useful in some ways, but I'll show you how to do it with a separate little tool where you can actually extract some of those features and make like a new vector file based on the query. Okay. So first, what I'll do is I'll just open up the properties, the same display manager that when you first loaded the vector in, and I did that simply by double-clicking on the schools. I could have right-clicked and gone down to properties, right, and it would have brought up this same thing over here. So in the tabs, you'll notice one of them says selection. All right. So if we go to that tab, we actually have a variety of options that we can use to select features. And this will just be for display purposes. We can make these permanent in the next step. All right. So first of all, the layer number, right? If we click on that, we actually see that there is the ability to select from the table attributes or from the other invisible one. In this case, they're calling it -1. All right. So we're just going to keep it layer number 1 because we want to select from the database. Now, GRASS will let you have multiple feature types in a single vector file, meaning you could have points, lines, and polygons in one file. All right. This is not always ideal. We tend to not want to have that, but we could have that. This next little line here that says input feature type lets us just narrow down into the specific kind of feature we're going to query. You don't have to uncheck these things if you have a file that's all points. It'll just by default only find the points. But it's good practice to just uncheck the things that you're not interested in and only leave checked the points, right? So these are schools. They're just X and Y points. We'll leave that here. The first way we could do it is if we happen to know the category number. This is like the ID number that you've been entering for your trees, right? If we knew that, we could certainly put a list of those here. Typically, that's unimportant because those numbers are arbitrary. They don't really mean anything for an analysis. So what we really want to do is build what we call an SQL statement. That is a database language for interacting with data in a database table. All right. SQL, you can spend a lot of time learning it. It's actually a very marketable skill if you're thinking about big data analysis down the line, employment and that kind of stuff. It's also a deep rabbit hole that we could fall into that we're not going to. Okay, GRASS makes it pretty simple because it limits you to just one little part of SQL, the part that we're interested in, which is pulling attributes that meet some criteria. Okay, and this is technically called a where statement in SQL, and it's a real pain in the ass to actually write a full where statement. Luckily, GRASS just wants you to put the easy part. Okay, in this case, what it wants you to do is to put the name of a column over here, and then a logical operator, and then the condition you want to meet. Okay, so I'll just demonstrate this right now. I'll pick one column that will be useful for us. Okay, and I think it's called G level, right? Grade level. And so we have elementary, middle school, and high school. Okay, let's say we just want to be looking at the high schools, right? They are H right here. You see the one that's highlighted? It says H. That's just the code, just like we used codes in our shapefile digitizing, okay? So over here, all we have to do is put G level, right, the name of the column. I put a space, I put an equal sign, and then in quotes, I will put the code. In this case, I have to use quotes because it's a alphanumeric code. Right? If it was just a number, I wouldn't have to use the quotes. But put the quotes for H, G level equals H, right? That makes some sense. So then we can just hit apply over here, and all of a sudden in the background you'll have seen a lot of things sort of disappear. And what I'll do is just change the symbol so we can actually see some of those things, because now there's quite a few less X's. Yeah, we need spaces between each of those three things for sure. Sorry about that. So let me just change that to pluses and click OK. Did I make a mistake in my selection routine? All right, so let's just, there should be 3 or 4 of them in this area. Oops. I might have to put quotation marks around the G level too, so let me just try that real quick.
What do the quotation marks mean?
It just tells it that it's text, basically. No, that's not true either. Hold on. I just did this earlier and it was working fine, so it's going on here. So it should be. Did I misspell G level? Is that the problem? G level. G level equals H. Yours worked? Yeah, okay. Well, did you put the quotations or no? You put, you just thought, yeah. All right, so it's supposed to work. So let me show you how to actually make that permanent. So instead of doing it in there, so what we would have seen if it had worked on my computer would be just a temporary display. It would mask out all the things that didn't equal that, but it wouldn't alter the file in any way. All right. So instead, what we'll do is actually make that permanent by going to the vector file menu at the top over there, selecting feature selection, and then select by attributes. And the little shorthand for it in GRASS is v.extract. Everyone see that? So I'll click it. All right. So name of input vector map. If it's not already selected for schools, just from the pull down, find schools down in here and select it. Name for output map. This we're actually going to make a new map, right? We're going to alter the old map. We're going to make a new map. I'm just going to call it high schools, right? And then we also have the same thing over here, the selection over here. We got the right layer number, and we're going to do the same thing where G level equals H. Now over here, we also want to do one thing. Just want to double check. This is not checked. Do not copy attributes. So if we wanted to ditch all the rest of the information in the table, We could check that box and we would just make a fresh blank vector points with no data in the table. Typically, we want to carry the data over, so we won't check that. And then there are a few other options over here. If we want to do this multiple times, we can check this box that says allow output files to overwrite. By default, GRASS doesn't want you to mistakenly overwrite your file. So by default, it doesn't have that check. But if you're doing this multiple times, querying and then updating and changing your query, you check that box so that you can just keep writing to the same file until you get it correct. All right? I'll leave it unchecked for now. I'm going to hit run. Boom. There. OK. So now it really did it. And we see those X's over there. That's our high schools. See these little X's everywhere? I'll zoom in again so we can see, generally speaking, this area here. So these little X's are our high schools, right? And if I open the attribute table for that new file that I called high school that we just made, you see that we carried over all the rest of the information, except that when we go to the column that says G level, we only have H's because the query pulled out everything that had an H there. Right? Make some sense? The operators that we can use in there are the standard operators. So we have equal sign, we have a greater than, we have a less than, we have a or less than equal to, right? Greater than equal to kind of things. We also have other ones like not, right, and or. Some of those will work in this statement, and some of those will not produce what you think. The more difficult thing is to query a statement like that from multiple columns, all right? And that will become a little bit more involved. Typically, we would probably do it in steps just to make our lives easier. We'd query all the high schools, make a new file, and then we would query from the new file, we would query something else, like whatever this thing that says T or M, right? We would query that and we'd make a third file. Right? We just keep doing that. You can do it all in one step. Personally, I think it's just to keep my mind straight and to make sure I don't screw up the statement. I just do it one at a time like that. Extract and extract and extract. And then the other benefit of that is that every stage is preserved. So if you want to go back, you can go back. There's a record of it, right? So that's the basic way to select information from the table and then actually use that to make a spatial file that's different, right? In this case, we selected just the high schools, okay? So if you're following along, hopefully you've made a new file that says high schools because we're going to work with that file next, all right? So what we're going to do is basic vector buffers, okay? And what we're going to do is a couple of different ways of making buffers, and we're going to do it arbitrarily. We're going to do it based on data, and then we'll use those buffers to actually do some statistical overlays later. So everything we're doing is sort of adding up, just so everyone knows. Okay? Okay. So we're looking at this. We got fire stations. We're not dealing with them yet now. We've got streets that are invisible for the moment. We have schools that we made invisible, and we have just the high schools that we queried out. What we want to do now is to create a buffer around the high schools because we're going to use that for some sort of analysis, all right? And we have to have an idea of what the analysis is. And I'll just give you a little preview. One thing that we could do is to count the number of major streets or just streets in general that are within a certain distance from the high schools, right? That could be a real useful analysis for city planning or something like that. If this is an archaeological area, we might want to count the number of streams in the vicinity of a set distance around the site, right? Or the number of other sites, something like that. So what we'll do is to go back up to our vector file menu. All the analysis tools, by the way, in GRASS you can get to them from the file menus up here, all right? And we will go down. It's very simple. There's only one tool. It's called buffer vectors, v.buffer, and it's right in the base menu, okay? So we click on that. When we get the tool, it pops up. Because I happen to have high schools over here already highlighted in the layer menu, it automatically populates it in the input vectors map. But if it's not there or if it's a different one, just select it from the pull-down menu, okay? We want to have the name for the output vector map. Again, remember no spaces and no dashes. Also, vector names cannot start with numbers in GRASS, so you have to put the numbers at the end, all right? has to do with database querying. You just can't have columns that start with numbers. It's just something that's like that, all right? So what I like to do is to maybe shorten it to something like high schools, without all the vowels and all that kind of stuff. I'll put an underscore, and I'll put buff, and then I'll put something like 200m, in that case 200 meters, is to remind me that I created the buffer, and I haven't done it yet, right, with 200 meters, okay? So I always like to give a descriptive name because it's your first little bit of metadata, the data that reminds you of what you did. You can always look at the history and get that, but it's so much better, so much easier to just do it in the name, right, in a shorthand form like this, okay? We could build an SQL statement here, meaning if we were working with the big schools file with all the schools, we could put that where G level equals H here, and we could just pull out the high schools. Again, I like to do it one step at a time so that we have a record of everything along the way. Extract the points, then make the buffers, okay? Then we have distance, okay? And this is where we can parameterize our buffers, and we can do it a variety of ways. The very simplest way to do it is to find this first field that says buffer distance along major axis in map units, and to put a number in here. Map units relates to how you're measuring the world. There are some map projections that use like feet and miles. There are some that use degrees, right? In this case, we're in a UTM location, I think. So we're using meters, right? So in this case, I put 200. It's in map units. It's in meters. If it was in feet, the map units were in feet, it would be feet, okay? Just something to keep straight in your mind. At this moment, we're good for now, so we'll just hit run. And it will chug along, and in the background, you'll see very small little circles popping up. And if we drag them just to below high schools, we can actually see the X's of the high schools in the center of them. And if I zoomed in on one of them, you would actually see the buffer, right? So there's the high school itself, and this is the buffer here. I can pull my little distance measuring tool, and I can drag a little line here. And I'm not being super precise, but you can see it's basically 200 meters, right? So it did it for us automatically, right? That's really cool. All right, so let's see. I'll zoom back to where we were. Let's say we didn't like 200. We wanted like a kilometer or something like that. Well, we would go back to our buffer tool. I would change the name over here to be 1,000 meters, right? I would go back to distance over here, and I would change 200 to be 1,000, right? Like that. I'd hit run. It'll chug along, and it'll make a new map over here in our layers. So we still have 200 over here. I can show it like that. Made a new map of 1,000, right? And we can actually see now the buffers are actually bigger, right? That's cool. So these are perfectly circular. That's very useful for many things because circles are kind of nice units to be sampling. But sometimes we want to do something different. We want to make maybe an oblong shape. Grass allows us to do that very simply. If we go back to our VBuffer tool and we go into distance, so we have a major axis and we can have a minor axis, right? So we can have 1,000 and then we can have 500. In this case, I'm going to select optional allow overwrite, because I just want to rewrite over that file that I made that said 1,000. If I hit run, we will see now we have these wide ones, right? They're just sort of oval shaped. Well, maybe I don't want the long distance to be that way. I might want it the other way. I could, over here, just switch the numbers, but we can actually rotate it with an angle around, basically starting from horizontal and going around, just like you're measuring an angle of something. So if I put 90 here and I hit run, we'll see that it flips so that the long axis is up and down. We could put 45 and hit run, and then 45, right? And of course, if we wanted to, we could also put negative numbers here, and it'll go around the opposite way around the circle. So we hit run, and we'll see it's negative 45 from horizontal, right? So So that's pretty useful if we have specific features that are linear or something like that that we want to sample around some sites or something like that. But what if we wanted to have a different size buffer around each individual point, right? How would we do that? Well, we could separate each individual point and make them into a separate vector file, and we can make separate vector buffers around each one of those things. But then you'd be at the computer all day, so we don't want to do that. What we want to do is actually read information out of the attribute table. If we wanted to, we could create a new column and we could manually put some numbers in there for each individual case. But instead of doing that, because it would take all day here in front of you, I'm just going to use some information that's in the attribute table already, and that may be actually kind of useful for us if we want to scale our sampling radius around this, around these high schools. Okay. So if I go back over to the attribute table for schools, and I kind of look and see what might be a useful thing. Remember, it's got to be a numeric column, and maybe it'd be useful to have this capacity. So this is basically the number of students that are in the school. Since we want to do an analysis of like the density of roads or something, maybe we should scale it based on the number of students that are in the school, right? And we can scale this in any way. We can do a very simple 1 student equals 1 meter in our buffer kind of a thing. Or we could say 1 student equals 10 meters or something like that. The way we would actually do this, to operationalize it, is actually in our same vBuffer tool. All right? So I'm going to go back to the first required column. I'm going to change the name of the output file here to be variable. I'm just going to be high school buffer variable. Okay? Then under distance, actually first we're going to go to selection. We're going to pick layer 1. We have to do that, otherwise we won't get the names of the columns out of this. So we'll pick layer 1. And then under distance, we actually have this thing over here that says name of column to use for buffer distances. Once we selected layer 1, it will actually show us the names of the columns that are in that attribute table. Okay? So I'll scroll down until I find that capacity 2 column, right? I'm going to delete these other things that I wrote earlier because we don't want to confuse it. In fact, it'll throw up an error if you have those numbers and you try and do a column, all right? Now, what we can do is to change the scaling factor. And this is just multiplying whatever number's in that column by the number in this field. By default, it's 1. So that means that it'll take that number in capacity 2 and just say this is actually meters, just straight meters in this case, in math meters. If I wanted to make it, 1 student is 10 meters, I would change this to 10, right? But it's actually okay for right now because some of the schools actually have like 2.25 thousand, kids, right? That's cool. That'll give us like 2.25 kilometer buffers. That's pretty big. So we're going to leave this alone. We'll just hit run, and we'll see a new set of buffers kind of pops up in the background over here. So I am going to close the other buffers that we made earlier, just so you can see that high school buffers variable is here. And you can see how some of them are bigger and some of them are smaller, right? This is based on their enrolled student capacity. Okay? Now, by default, we made sort of a brand new vector file with no attribute table at all. So if I try and load the table for the buffers file, it'll say there is no table to load because it only has that layer 0, its spatial attribute. So I could click OK. It will load up a blank table manager, and I could actually make a table at this point. I can make a brand new table and attach it. That might be useful for some operations, but since we already have data from the schools, we want to bring that data over. And that is actually, you can do that again back in vBuffer. There's a tab that says attributes, and there's only one option that says transfer the table between the original points file and the new buffers. So we'll just click that. Again, remember we have allow overriding enabled. So we'll hit run. It'll do the same thing. The imagery won't change very much, but when we go to load the table, it will now have all of our same attributes from before brought over to the vector buffers file, which is really great. You're propagating all the information so that now you've got a brand new polygon file of a buffer around these high schools and all the information about the high schools brought over from the points file. All right, you see how you can choose to make these information propagate or not? So it's really important that you're sort of aware of that as you go through these stages, that if you want the data to propagate, you have to continually make sure you're selecting to have it propagate. Any questions thus far about the querying and the buffers? Does it make sense watching it happen a little bit in reality? Okay. So now we have vector buffers around points. What if we wanted to have vector buffers around lines or around polygons? We can absolutely do it. We can do it with the same tool, vbuffers. It's just going to show up. It's going to, when we look at it, it's going to look a little different. Okay. I'm just going to show you the data table for streets. It's actually got quite a bit of information in it. So it's going to take a while for the database to actually load. So you see it's sort of doing its thing here because it's got like a ton of data in it, right? There we go. Oops. All right, so I'm not going to go down and show all the rows because there are a lot of rows in the file behind us, but just showing you all the columns over here. And an interesting column is speed, right? And if we look at it, some are 25, some are 35, some are 45, and some are 65, right? So this is the speed limit, obviously, of the roads. If I tried to do a vector buffer now around all of these tiny little roads, this little computer I'm working on right now would seriously struggle, and it would take probably 20 minutes or something like that, right? A better computer would go faster, but I'm not going to waste 20 minutes here, so I'm going to extract the fast roads, all right? So I'm going to do the same thing we did before. I'm going to go to vector, feature selection, select by attributes, v.extract. I'm going to select streets as my input, and I'm going to put fast roads as my output. And then in the selection, I'm gonna look at the name of my column. It's called speed, right? I'm going to go down to my where statement. I'm going to put speed greater than or equal to 45. Notice that I did not put quotes around 45, right? Because it's a numeric value, you don't need the quotes. You only need the quotes if it's an alphanumeric, like a character value, okay? And I'm going to hit run. It will chug along. It's actually going to take a little while because line and polygon attributes are a little bit more complex to write. The topology is a little more complex, so it takes a little longer, especially for a little computer like my old netbook over here to do it, right? But it finished, and I actually have in my layer tree over here fast roads. If I make the original streets invisible, now we can actually see a much simpler vector lines file. Right? We got rid of all the little streets, and we only have the big streets. Okay? I just did that because, well, it's actually potentially a useful thing to be able to do to analyze. Maybe we only actually care about streets that are faster than 45 within some vicinity of our high schools. That's actually a very legitimate kind of query that you might have. All right? Let's also make buffers around this. Let's say our justification is that people ride motorcycles and it's loud, right? Or they have souped up cars and it's loud. And we want a buffer that says this is the loudness zone. That's what we're kind of interested in, okay? So we got fast roads selected over here. I'll just grab vbuffer again. And we'll go to distance. And we'll say 200 meters is our sort of audible zone around the fast roads. It says you're in the fast, loud, fast and furious zone, right? All right. We can hit run. Whoops, I didn't put the name of an output one, sorry. We just put fast roads 200M buff, right? Hit run. Again, it's going to take a little while. It's a little more complex to draw the buffers around the roads because there's intersecting buffers, and it's got to clip out where the intersections are. That's what it's doing right now. It's breaking boundaries. It's actually taking care of the topology for us. It's quite intelligent. You'll notice since it's taking quite a long time with just our little thinned fast rows, imagine how long it would take with the other one, right? Vector operations are actually quite computationally intensive to do this kind of thing. So it's useful to do, if you're going to do big operations like this, it's useful to use a more powerful computer. Not impossible to do it on a small machine, but it just takes a little while. And now it's rebuilding the areas. It's cleaning up things like dangles and centroids and aisles, and these are technical terms for little broken pieces of topology. It's automatically cleaning them, and it's getting rid of anything that was basically not topologically correct, things that would cause errors down the line. Tiny little polygons that are not real. They're just artifacts of when two things overlap, okay? And then it's done, boom. Now we see behind us the buffered roads, all right? I just want to point out that if you're doing buffers around something like lines, really it only matters the major map axis. The minor one's not going to do anything at this particular point. All right? It's actually going out at a 90-degree angle from the road itself, the distance that you entered into the buffer line, okay? You could, however, choose a column in the attribute table, and depending on which road it was, it could make the buffer bigger. So the faster the road, for example, we could make the buffer bigger because the cars are going faster, the sound is larger. For simplicity's sake, and because it takes a little while to do on my computer, I'm not going to show that for the moment. Basically, I'm just going to show how we have two separate buffers. We have a buffer around the high schools, which is this one called high school buffer, right? And then we have the buffer around the roads, which is called fast roads buffer. If I drag that underneath fast roads, you can see the road will overlie, right? So remember, we're just setting our layers over here. This has nothing to do with any real 3D overlap, okay? So everyone followed up until this point, and it makes some sense? We could also do a buffer around a polygon. And one of the kind of useful things that we might want to do is to add a second layer of buffering around our initial buffers, right? Around the high school buffers, right? So I'll click high school buffers just over here. I'll go back to my V buffer. I'll have high school buffer variable, and I'll say, I'll just sort of copy the name over here, and I'll just put with another 200 meters around it. And I'll just go to distance over here, and I'll put 200 meters. Now, here's something that will make a difference about which one of these things we have enabled. So I'm just going to leave it by default right now, and you'll see what might happen. All right. So let me make those things kind of go away for now. All we got is bigger circles, right? If I put this below, we can see the original buffers are the sort of smaller ones, and then there's another one that's 200 meters bigger than that. By default, it's going to make a full circle buffer from the center of the school. It's just going to make it be a little bit bigger by the number that we put in there, 200 meters bigger. If we actually wanted a ring, we would have to do something different, all right? Sometimes we want to just make a slightly bigger circle. That's cool, but if we wanted a ring, what we would have to do is to go back to VBuffer, and in our selection tab over here, we would actually have to get rid of everything except the boundary. And the boundary is the outer line that encloses the polygon, all right? If we hit run now, actually if we hit, we have to overwrite, because we're going to overwrite that, right? If we hit run now, when it chugs through, actually, did it do it? Am I showing the right one? High school buffers, variable, selection. Oh, I have that thing selected too. Don't have that area selected either, okay? Now hit run. There we go. Now we have rings, because now it's actually buffering from the edge of that initial polygon outwards. Before, it was actually buffering, like adding to it too, yeah.
Do you just have it on the -1 side?
Yeah, we're not doing anything with the layer at this moment. So over here in this VBuffer, if we were going to query from the data table, that's when we have to put layer 1. when we're not querying from the data table, we're actually technically working only with the spatial information, which is in this case layer -1 or layer 0, depending, right? So we don't have to deal with the layer number here. We just actually have to deal with the topological feature that we want to buffer from. So do we want to buffer from the area, the actual gray part, or do we want to buffer from the boundary, the black line that surrounds it? Or do we want to buffer from the centroid? So if I did that, centroid, and I hit run, we'll see something very different. We'll actually see very, very small circular buffers because it's actually only buffering 200 meters out from the centroid, which is actually it's a point that's in the middle of the area, right? That's the center of the area. Does that make sense? So we choose which feature we want to draw the buffer from when it's a polygon like that. We can draw different kinds of buffers, okay?
You can do it from the properties, is that different?
From the properties?
Yeah, by like double clicking and going to the like, properties instead of going to
Oh, no, because the properties will only be for display.
Oh, okay.
So it'll only change the way it's displayed, but it will not change the way VBuffer starts and
Okay.
draws its things. So if you want to make the buffer different, you have to change it in VBuffer in the selection tab,
Okay.
right? We can always usually select this in the display things. It's just for visual purposes. In the analysis tools, it will actually do it numerically
Okay.
based on those things.
Or do you do that like just to see if that's like something you want to do and accept from the links and then you go to debuffer?
Yeah, you could, well, depending on what you're trying to display. If it's just a
Yeah.
query, you could certainly do it just graphically.
Yeah.
But for something like buffering, because it's actually growing the buffer, you wouldn't be able to actually see anything if you did it in the display. It wouldn't change the visualness because you haven't made a buffer yet.
Right.
Yeah, you're actually making the buffer in the analysis. All right. So I'm going to close that, and I'm going to open up our original variable buffer in our fast roads buffer, right? So that's kind of what I'm working with now. I'll just get rid of fire stages for the moment. So any questions about buffering and the different types of vectors? Okay. So one thing that you might want to do, let's say in project 1, is to draw a buffer from like the historic properties, right? You could definitely draw buffers, and then you could count the number of trees within that buffer, and we'll show you how to do this here in just a little bit, all right? But before we show how to count stuff, we're going to do overlay operations, meaning how do we combine two separate vector layers into a new vector layer. This is where we're going to use some of our logical operators, but not these ones. We're going to be using the ones that are like or, and, not, and then something called XOR. Okay, so these are like logical operators for the overlay of the two buffers. Okay. The tool that we're going to use is under vector again, and we go down. We have to find the one that says overlay vector maps, and then there are two tools. Patch vector maps is a really simplistic tool. If all you want to do is combine them so that they're just two, basically all the points and the lines and all this stuff are just in one file, without any topological management, use vpatch. Most of the time, however, we want to combine it in an intelligent way, a kind of statistical overlay kind of a way, all right? So we'll pick the one that says V overlay, and that gives us a lot more options, all right? All right. The first thing is that you'll notice that there are now more things in the first required tab. Name of input vector map A, name of vector map B, operator defining it, and the name for output map, okay? This is where the concept of layer order will become important, because we're going to do this in order. A and B, what you put in A and what you put in B actually will matter for the logical operator that you use, because you're going to draw an equation where it'll be something like A or B, and it may actually make a difference if A is first or if B is first, right? Make some sense? So I'll show you how this works. We will pick the first one, A, we'll pick it to be fast roads buffer. And then the second one, B, we will pick it to be our high school buffers with the variable size that we did earlier based on the student population, okay? The output, we're just going to call it A school roads combined, something like that. In this case, we're not going to do much analysis on this. It's kind of a throwaway just to show you what it's going to look like. Now we pick our operator, all right, and or not XOR. So I'm going to do each of these one at a time. We'll just see what they look like. That would be the easiest way, I think, to make some sense of it, okay? So we'll pick the first one. So it'll be fast roads buffer and high school buffer. There are a variety of other things that you could select over here. Mostly I'm just going to select this overwrite, even though there's nothing to overwrite right now because I'm going to do this multiple times, okay? So I'm just going to move this over so you can see how it works. All right, it's going to look like nothing has changed, and nothing really has changed. So if I kind of close the buffers, now you can actually see what it did, all right? This is the file that it actually made. And basically it said wherever there was the road buffer and there was also the high school buffer, that's where we're going to make the new map. So it doesn't care if there was a road buffer outside of it, right? Or if there was a high school buffer outside of it, it's going to ignore all that. Only where they actually overlap is it going to do anything. So let me bring this up to the top. Let me put high school buffers back on over here. And I'll just change the color of it so we can actually see the differences as we kind of go through here. So colors, I'm going to make this be just this sort of green color. Actually, I'll make it this pale green color. Click OK. Okay, so that's the green color, right? And then we have our fast roads buffer over here. If I make that visible again, what I'll do is I'll make that be like a pink color. All right. So now we can kind of see what's going on, right? Makes some sense. So anywhere where, okay, the pink looks really terrible. I'm sorry. Let me change it to something more visible. Let's change it to this blue color. Can we see better now? Okay. So basically, the gray part is what got selected for, and we made the new feature. The other colors are from the other two separate A and B before, okay? So that was the AND operator. Let's check out the OR operator. We hit run. I'm just going to chug through it. Boom. So now it was A or B. Now it doesn't matter. It doesn't care, actually, about any of the overlap because it's actually all of A or all of B. Even where they overlap or where they don't overlap, it doesn't matter. All right? We'll do the next one, which is not, right? And this is where the order is going to matter more, okay? So we hit run. So we have A, not B. And when it chugs through, you'll see, it's actually showing us the gray wherever there wasn't a school buffer, all right? Does that make sense? And if I switch the two, for example, if I put that one over here, if I make this one be the roads, let's see where we fast roads buffer, and we make the first one be the high schools, and we hit run with the same not operator, we'll see what that does. Switches it again, right? It's the gray again that we're interested in, showing us the high school buffers where there is not roads that are faster than 45 and 200 meter buffer, right? And then finally, we want to do the last one, which is probably the trickiest one. It's the XOR. It's symmetrical OR. I think rather than me trying to explain it, I'll just run it and we'll see what it does. All right, there we go. So this is kind of the opposite of the AND, right? So anywhere where the AND might be picked, it would actually do the opposite, right? So it's like inverting the AND. So you see the only colored part is where there was A and B. And in this case, it's the exact opposite of what you want. So the XOR is kind of, in your mind, just think of the opposite of AND.
How is that different from like the not? Because it's
Yeah.
the same.
Actually, not is slightly different than that because we wouldn't see both of these two files in the gray, right? Remember, the gray is the new one that we created. That make sense? Any questions about those kind of overlays? We kind of, yeah?
I do.
Yeah.
Or can you show it just isolating that specific,
The OR?
the or here?
Yeah,
So
I can show the
we won't
or.
see the rest of it, just the or?
Sure, yeah. So I will make those things invisible. And then I will run an OR. So high school buffer or the roads. And you hit run. You'll see it'll actually look as if we just patched them together when it's finished here. Boom. So technically, if you use the simple tool that's called vpatch, the one I said that you might want to use it, it would actually show up like this.
How do you use the or then if it's showing both?
Yeah, well, if you just want to combine them into one file, that's when you would use the OR for the most part. The other ones, you're combining them into one file, but you're actually clipping one based on the other, right? Make sense? Okay. Now we're going to go down to the next one, which is that was the overlay operations. We'll do statistical operations. Okay. So at this point, what we're going to do is to bring up our fire stations and our high school variable buffers. And then eventually we'll also do the roads too. Okay, so that's basically what we need. We need the elevation file in the background, the high schools, and the fire stations, and the high school buffers. What we're going to do is actually a very simple statistical overlay. We are going to count the number of fire stations within the buffer around each school. All right, this can be really useful for a variety of things you want to do archaeologically, counting sites in the vicinity around each site, for example, something that you might want to do for an analysis. Counting other things in the vicinity of a site is another thing that you might want to do. The way we do this, again, everything's in our vector file menu from the top. We're going to go down this one that says update attributes, and you'll see that there's actually quite a few potential tools. We'll go through most of these, if not all of them. All right. We have VRAS stats, update area attributes from a raster. VVet stats, update area attributes from vector. VWhatVet, update point attributes from areas. V2DB, update database values from vector. VWhatRast, sample raster maps at point locations. And then VSample, which is sample and neighborhood round points. Okay? So we're going to pick the one that says update area attributes from vector VVect stats. So we'll click on that. And then we'll pick as our input vector map the high school buffer that we made, the variable buffer. And, the points that we're going to count is what we're going to pick first. We're going to pick fire stations. And then the areas, the second one down here, we're going to pick the high school buffers variable. Okay? And then optional over here, we have a variety of things that we could do. But what we want to do is to actually count a name here, column name to upload points count. Now, some of these things, if we had the right layer number, we could actually select them for. But this particular one for counting, we just enter the name of a new column. So this would be FS_num. I'm just going to do that, number of fire stations, all right? And that's basically it. We just hit run. It's real fast, really, really fast. If we go back to our buffer, high school buffer file, and we open the table, we will actually see a new column in the table. So if I scroll all the way over to the end, is where we'll put it, FS_num, and actually we have a count right now. Literally, it took that much time. It counted for each individual school buffer, it counted the number of these squares that were in it, which saves you lots of time. All right, so you don't have to do that manually. So that's something you're definitely going to want to use probably in Project 1, right, when you do the analysis, counting in a buffer, very simply. Okay? You could do that in a buffer from the historic sites or from parks, or you could just do it in your grid square to real quickly count the number of trees you actually digitized, right? There are a variety of ways that you can use this tool to do the count. And it would enter them directly into the table, and then you could take that information out, do whatever you wanted with it at that point. If we had other things that we wanted to calculate, including values in the input table of the points, we could aggregate them. So basically it would not just count the number, but it would say, okay, these are the ones that are within the buffer, right? Here's the column I'm interested in, the number that's in the column. Here's the mean, average, min of just the sites that are within the buffer, okay? If we wanted to do that, it's a little more complex. We would have to find the value that we want to do, like median or sum or something like that. And we would have to find the column name to use for the statistics, which is actually missing here. So we would pick, let's see, what is in fire stations? What that we could pick, I forget. So let's see. Any number here that might be interesting that we want to do. Let's say water risk, whatever that means over here. Let's see if we can do this. And then we'll just give it a new name over here. We're going to get rid of this one. We'll put fsstat. We'll just hit run. Count column. Oh, whoops. What did I do? I'll just put this back in here. All right. So now let's go back to our table, which is in the background over here. So this is our table for our buffers. We'll hit refresh, and actually we'll have to reload the table because we added a column name. So let's see, high school buff variable. Okay. And if we go over, we actually have the stats. So it's actually, in this case, it was summing the values, right? So if there were two fire stations and one of them had one fire water rescue and the other one had one, it would sum them, and the number would be 2 in there, right? If one had 1 and one had 3, it would sum them, it would be 4. If they both had 0, it would sum them, it would be 0. And when there's no data, that means there was no fire station in the vicinity, and you can confirm that because the number is 0 over here, right, when we uploaded those two columns. Does that make sense, what just happened? So it took the number from the column of the fire station. If there was more than one fire station, it would, in this case, we asked it to add it together. We could have asked it to give us the average or the maximum or the minimum or anything like that. Does that make sense? Okay.
Can you do another example of like how to do the stat, something like that, or combine two of them?
Sure, yeah. Let's take another look at a column in the fire stations. Fire stations don't have really great columns for this. They're pretty basic, but let's take a look and see what we can find.
Stats is killing me right now.
So let's see, CV lag. Well, that's a decimal number. I have no idea what this actually means, CV lag. Well, let's do that again. And we're going to overwrite this fsstat column just because it's a little simpler to do that. We can make a new column if we wanted to. But if we're back here, right, fire stations and the buffers, under optional, we have fsstat is the column we're going to write this to. And instead of water risk, we're going to pick CV lag is what it was called. Okay. So I'll just write that in here. CV lag. And instead of sum, we'll take the average, right? So it's gonna, if there's more than one fire station, it will average the value of CV lag between them. And we'll hit run. We'll go back to the attribute table for the buffer. We'll hit refresh, and we actually get new numbers in there. These are the average. In this case, they were 2 fire stations. The average value of CV lag between those 2 fire stations was 1.4. In this case, everyone else has either 0 or none. Most of them only have 2, right? And this has a value, average value of 0.615 between the 2 fire stations that are within the buffer, and ignoring all the rest of the fire stations. Does that make sense? So we're actually querying by space first. We're actually querying by overlay, and then we're doing statistics based on the results of that query and bringing them into the table of the buffer we use to query by space. Okay. So let's do the same thing, except let us, I missed one thing that I wanted to show you before. Let me just make sure I'm not missing anything else. Deselect roads. I forgot to do vector select by overlay. All right, so let's go back just one. It'll be real quick. We'll go back to feature selection, select by another map, actually, is the thing I forgot to show you. So we were doing select by attributes before, where we were doing our database query. Now we'll do vSelect, which is select by another map. This will be real simple. The A input, the one that we're going to use to do the query, is going to be the same one we just used to do this query. So we'll pick the high school buffer variable. And the other one is going to be the roads, not the road buffer, but the actual roads itself. So fast roads, the one that we made earlier. And the output will be fast roads near schools, okay? There's a couple of operations that we have here. We'll leave the first one as overlap. I'll hit run. And in the background, oh, did I put it the wrong way around? I think I might have had to put the roads first and then the other one second, okay? So fast roads and then buffers. And of course, I got to make sure I'm allowing overwrite. And then we're going to hit run. There we go. All right, so now we see it selected the roads that were within the buffer. We could do the same thing with points, and we could make a brand new file of just the fire stations that are within the buffers, right? This is separate from the querying and bringing stats over. This is literally making a new vector file based on the overlap between the 2 of them right there. And here we see something strange, which is that some of the roads go past the edge, right, of our buffer areas. I'll just zoom in on that. You see how these roads kind of go past? And the reason why we selected an overlap. An overlap isn't that contains. It's if there is any overlap between an arc, a segment of road, right, an individual segment of road, and the circular buffer, it's just going to pull that segment of road and make it into the new file. Some of them will be wholly contained within them. Some of them will not be, all right? As long as there's any overlap at all, it's going to pull it out. If I instead choose a different method, let's say I pick within, and I hit run, you're going to see a very different output. So now, anything that was actually going outside the circle is not going to be in the new file. Only things that are fully within the buffer circle are going to be in the new file. There are a variety of other ones in there that you can fool around with. Some of them do things that are intuitive, and some of them do not. So here we have intersects, and it doesn't look that different from overlap in this case. But in other cases, it will be. If you had actually 2 lines, the intersection of 2 lines is different than this. Okay, so it just depends on what you're querying with the other one. And I should have also showed you earlier that all of these things have manual pages. So the last little tab is manual pages. And a lot of them are very, very, very extensive with really great examples of what each of those operators mean. All right, so this particular one for vSelect is really extensive, and it's actually using some of the North Carolina data as the example, so it's really helpful for you. Okay. So sorry for getting out of order, but let us now get back to what we were doing before, which was doing the statistical overlays, and the queries that combine the overlays, all right? All right, so we did VWhat vect. Now we're going to do VWhat rast. And we haven't done anything with the elevation file yet, but now we're actually going to do something with the elevation file. So the data that's in the elevation file is literally just elevation above sea level. And it might be useful for us to pull some of that information from the raster file of elevation into the database, the table of our sampling circle. Because maybe we want to know the average elevation or the min and the max elevation within that buffer around the school or around our site, for example. That could be a really useful thing that we want to do. So the way we do that, we go back to our vector update attributes, and then we pick the one that says VWhat rast. Actually, sorry, VRast stats, because we're using areas at this point. Okay, VRast stats. So we pick our buffer as our input map, and then we pick our raster file. We want to pick the elevation, right? And what's going to do is it's actually going to make quite a few new columns automatically, because there are a variety of statistics we could upload. So we're just going to give it a prefix, and then it will fill in the rest of the name of the column. So you want to keep the prefix short. I'll just call it elev. I'll put a little underscore there just so I can separate the prefix from what it automatically adds. Okay. Then I will go to optional, and I have all of these things over here that I can check or uncheck. All of these are statistics that it would upload for me if I wanted it to. I happen to not care about a lot of these things, like the sum and the quartile or the median or anything like that. But it's really useful to have the standard deviation and the average, right? It's really useful to have the minimum and the maximum. In this case, I don't particularly care about the number of cells, because that's not something that's interesting to me. So I just want the minimum, the maximum, the average, and the standard deviation. So we should be good to go here. And we hit run. It's going to take a little while because it's actually has to read in the statistics from underneath. And there it goes, updating the database. And so now let's go back to our high school buffers variable, open up our table. Here we go. If I scroll all the way over to the end, we see a bunch of new columns. elev underscore minimum underscore maximum average standard def, right? And basically what it's done is filled in. The ones that are blank are the high schools that are off the raster map, so there's no data to put in there. But the ones that have numbers are these ones over here that are on top of the map. And basically it's given me those numbers right there. You see? The minimum and the maximum elevation, the average elevation, and then the standard deviation. And from that, I can actually do a lot of other statistics in a different program if I want. That make sense? What if I just wanted to sample exactly where the schools are and I don't care about the other stuff, right? If I want to sample only where the schools are, I would use a different tool. I would go back to my update attributes, but I'd pick the one that says VWhat rast, sample raster maps at point locations. So instead of areas, we pick the one for points. So we pick that one here. Instead of the buffers, we're going to pick high schools by itself. We'll pick the same raster map of elevation, and we don't really need to do very much over here. We could pick an existing, actually I think I might have to make a column, but let me just try this real quick and just say elev and hit run, and if it gives me an error, no, okay. So where's my high school? I got a lot of layers over here. There we are. Okay, so we're going to open up the high school attribute table. And when I scroll that all the way to the right, we'll have elev over here. And now where there is a high school that is on top of the elevation file, it pulled just the one pixel that the point that I digitized is sitting on. And it didn't care about any averages because there's nothing to average. There's just one pixel. All right? So that's really, really, really useful as well.
I have a question.
Yeah.
Given that
because there are some schools that are actually outside of the boundaries of the raster map. If the raster map covered the whole area, then it would have sampled them. But if there's no data to sample, it won't bring anything in. Right? Make sense? All right. So basically what we've done here is either using a polygon to define an area to calculate the average min-max in, or a point to say this is exactly where I want. We brought information from the raster file and we put it into our table associated with our vector format. We could do the same exact thing from one vector to another, right? So instead of v-ras stats, we would choose v-vect stats, right? So in this case, we would have one set of vector polygons and then some other vectors underneath, and it would do the same thing. It could bring the average, mean, max, all that stuff over. And the same thing with points over here. There's v-what-vec point, and bring the values from areas or from polygons into the points. All right? Let's see what time it is. We're almost done here. What I did not get to do is the nearest feature, so I'm going to very, very, very quickly show two things, and then if you got to run, run. But I'm going to show two things before everyone has to run because they're kind of important things too. The last little query thing is this one that's called update database values from vector, v to db. This is unintuitive. What it is it's actually going to take information about the topology of the vector and put it into the table. So one thing we might want to do, for example, we have buffers. We want to know the area, right, that is enclosed within the circular buffer. We can do that automatically with this v to db tool. So we'll just select our variable buffers for the high school. From the pull-down menu, we'll pick area, and we'll call this area. We'll hit run. All right, and then we'll look at our attribute table again. And the newest columns always appear on the right. Where did it go? Should have been there. Actually, I think I may have to make the column real quick, so I'm just going to make the column, call it area, leave it integer, hit add, and then I'm going to run that again. There we go. No errors that time. So now we have area, which is over here, hit refresh, and that's the square meters that are within each of those buffers that we made, all right? And there are a variety of other statistics for that. Now, one last thing. I'm going to close a bunch of this stuff because it's getting very cluttered over here. We want to actually calculate the distance between a high school and the nearest fire station, or the nearest road we could also do, right? This one is under vector, and let's see, it's, where is it? Nearest features right there, v.distance, okay? So existing vector map from, we will pick our high schools. And again, I'm just going to do this even though we know it's points file, right? We're going to leave everything alone here. Everything, this is the to tab, so we're going to pick, in this case, fire stations, right? And we'll give it a name to upload, so dist to fs. And then we can also make a new vector file of the actual line that connects the school to the nearest fire station. So we'll have nearest line, all right? And we'll just hit run on this. Oops. What did I do wrong? I'm doing this fast. Sorry, parameter uploads is missing. Yeah. Minimum distance is what we needed to put here. Hit run. What did I do wrong again? I think I forgot about the column. Yeah, I didn't make the column is the problem. Okay, so high schools, column. Let's pick this thing again. Well, some of the tools will make the columns automatically and some will not. We'll just call it dist we'll add it over here. I'll leave it off to the side, and I'm gonna actually you know what? I put this in the wrong map. It should be in this one over here. This one should be dist. There we go. Okay. So first off, just graphically, you can actually see it do the line. That's a separate file, just called nearest line over here, and it shows you just graphically which is the nearest fire station in this case. And then here's the attribute table over here. Dist, I'll just refresh, and actually that's the linear distance along that line to the nearest fire station. We could have selected a couple of different ways for it to select which one is the nearest. For points, it doesn't matter so much, but if we had lines, there are a variety of ways to measure what's the nearest point. Is it just the nearest straight arc or the nearest vertex or some of these other things? So we could select that in there, all right? For us in our analysis, we probably want to just do point to point or something like that at this moment. All right, so that's basically it for now. We kind of rushed a little bit at the end, but we'll have time. The lab will be open from 1 to 3, so if you want to come down, we can do some of this in more depth down there. All right? Okay, thanks.